Hey guys, let's take a look at our rational zero theorem, or sometimes you'll call this the rational root theorem. So rational root, whenever you see me use RR, that's what we mean here. But basically, we say given any polynomial in standard form here that has integer coefficients, we say that the only rational zeros that could possibly be zeros of this function have to be of the form P over Q, where we basically say that P represents all the factors of our constant term, or this term out here on all these polynomials. It doesn't have a variable over all the factors of our leading coefficient, which is this thing, if you've got it in standard form, which is the leading coefficient. So to make this list, it's quite easy, but just what I want you to know is that what it does is it gives us a list of possible rational zeros that could be potentially zeros of this. If it's not on the list, then it could never work. So for number one, for instance, here we would just say our rational roots list here. Remember that factors can be positive or negative, and so we could say plus or minus out in front. But factors of 4, I would just say, are 1 and 4, and 2 and 2. So 1, 2, and 4 over the factors of the leading coefficient, which is 1. I always want you to clean this list up, but what we're saying is the only factors that could work for this are 1 over 1, 2 over 1, and 4 over 1. And one thing that I want to make sure you do with all of these, please, when you find this list, is I want you to go take your calculator, go put this function in. So we have x to the power of 3 plus x squared, okay, minus 4x minus 4, and graph it. And I want you to see that the zeros we get here looks like -2 and -1 and +2, but those were all three of those on this list of numbers right here. And so that's the great thing about this rational roots theorem. It gives us a list of zeros to potentially work into our function, and we can see that these zeros that the function has have to be on this list. So check out what you see with these other ones. Cheers.